Welcome all to this session of Maths, the number game. Today we shall study the method of finding square roots by prime factorization. What is prime factorization? It is a method of splitting a given number into its prime factors, which when multiplied gives back the original number. For example, the prime factors of 30 are 2, 3 and 5. That is, 2 into 3 into 5 is equal to 30. Example 2. The prime factors of 231 are 3, 7 and 11. 3 into 7 into 11 is 231. Tools for prime factorization. Tools? Yes. Let us take an example of putting a nail into the wall. How do you place the nail in the wall? We need a hammer. To cut an apple, we need a knife. Similarly, to do this method, we need certain tools, which will be very helpful to make the method much easier. Let's list the tools below. Tool 1. Prime numbers. You need to know the prime numbers between 1 and 100, which are around 25 or even more. At least a few of them would be very helpful in doing this method. 2, 3, 5, 7, 11, 13 and 17 are some of these numbers. The next tool is the divisibility test. Do we have to study all these tests? No, not at all. A few of them would be sufficient. For example, the divisibility test for 2, 3, 5, 7, 11, 13 is maybe more than sufficient. Let us see some of the divisibility tests here. For example, if a number ends with 0, 2, 4, 6 or 8, then the number is divisible by 2. If the sum of the digits of the number is divisible by 3, then the number is divisible by 3, and so on. Tool 3. Short division method. Short division? Yes, we shall learn the method as we do these sums. The tool 4. That is the table of squares. This has been explained in the earlier videos, where 1 into 1 is 1 square, that is 1. Similar, 2 into 2 is 2 square or 4, so 4, and 3 into 3 is 9, so 1, 4, 9 are the square numbers. So that was known as the table of squares, which if memorized would be of great help. Now with these tools, let us study the method of finding the square roots by prime factorization. Step 1. Find the prime factors of the given number. As we had discussed the tools, we will be splitting it into these factors. That is, 144 is 2 into 2 into 2 into 2 into 3 into 3. The step 2. Pair the prime factors. So these are arranged in ascending order. We pair each of these numbers. So 2 into 2 is one pair. The next is 2 into 2 is the second pair, and 3 into 3 is the third pair. Now take a number from each pair. So we take one of the numbers, that is for 2, and again here this represents one pair and this represents the last pair, that is 3. So find its product. 2 into 2 is 4, 4 into 3 is 12. So square root of 144 is 12. Let us take an example. 1764. Let us study how to use the tools to find these factors. 1764 is divisible by 2 because the units digit is an even number 4. Now, we shall use the method of prime factorization to find the square root of 1764. So we start with the smallest prime, that is 2, We check for divisibility. Yes, it goes in 2. So let us start short division. You must be wondering what short division is. Now let's take the first 2 digits. 2 goes into 17 8 times. For example, that is 2 8s are 16 and you are left with a remainder 1. The remainder is carried over to the next digit. Now 2 goes into 16 8 times. So 2 8s are 16. The remainder here is 0. Now what are you left with? 0 and 4. So 2 goes into 4 2 times. So 2 2s are 4. So we have done it in just a single step instead of doing the long division method. This method is known as short division. As we go further, you will get a better understanding of short division. Now let us take the next number. We note that since the last number is an even number, 882 will also go in 2 times table. 2 goes 4 times 8. 2 4s are 8. So again here 2 4s are 8. There is no remainder. So we can continue. Again 2 goes into 2 1. So 441. Does 441 go in 2 times table? No, definitely not, because 1 is an odd number. So let us check for the next divisibility. So which is the next prime after 2? It is 3. So 4 plus 4 plus 1 is equal to 9, and 9 is divisible by 3. So 441 is also divisible by 3. That's the test for 3. Now let's do short division. 3 goes into 4 ones. So 3 ones are 3. So you get a 3 here. The remaining or the remainder 1 is carried over to the next number. Now 3 goes into 14 4 times. 3 4s are 12. Now what is left over here? 2. The remainder is carried over to the next digit. So 3 7s are 21. So you get the answer 147. Now let's go to the next number. Again 3 goes into 14 4 times. So 3 4s are 12. So you get here 12. The remainder after 14 is you are left with the remainder 2. That is 27. So 3 goes into 27 9 times. So 3 into 49 gives you 147. Now looking at the table of squares, which is the tool 4, the fourth tool, you know that 7 into 7 is 49, which is there in the table of squares. So we get all the prime factors using the 4 tools. We have made it very early or very fast. So the prime factors of 1764 are 2, 2, 3, 3, 7 and 7. Now as I had listed out before, the next step is to pair them. So we have paired them 2 into 2, 3 into 3 and 7 into 7. There are 3 pairs and each number will represent one pair. So 2 represents this pair, 3 represents this pair and 7 represents this pair. So we are left with the product, the last step. So 2 3s are 6, 6 7s are 42. So 42 is the square root of 1764. Let us take another example of 676. Let us check the divisibility. Yes, it is an even number. Since it is ending with an even number, we can say it is divisible by 2, which is the smallest prime. Now let us start dividing by 2 by short division method. 2 goes into 6 3 times. So 2 3s are 6. Now there is no remainder, so it is a 0 here. Now 2 goes into 7 3 times again. 2 3s are 6. Again here this is 7. So you have a remainder of 1. So this becomes 16 because 1 is carried over to the next number. So 2 goes into 16 8 times. So 2 8s are 16. Now let us carry on. Since it ends with 8, again it is divisible by 2. Now 2 1s are 2, you are left with the remainder 1, 2 6s are 12, again you are left with the remainder 1, and your 2 9s are 18. So you get the number 169. Now from the table of squares, that the last tool or the fourth tool, you know that 13 square is 169, or 13 into 13 is 169. So here we are with the prime factors of 676, that is 2 into 2 and 13 into 13. Now by pairing them, we got, and representing each number, we get 2 is represented by 2 into 2, 13 is represented by 13 is represented by 13. So the square root of 676 is the product of 2 into 13, that is 26. Now, a small tip: in any square number, factors are always in pairs. Have you noticed that? You have a pair here, you have a pair here. So we notice that in a square number, the factors are always in pairs. Let us take an example of 1089. Is it divisible by 2? No, not at all, because 9 is an odd number. Now what is the test for the next prime, that is 3? We have to add all the digits of the number. So 1 plus 0 is 1, 1 plus 8 is 9, 9 plus 9 is 18. And 18 is definitely divisible by 3. So this number is divisible by 3. So let us do short division. 3 3s are 9. So what are you left with? This is 9, you are left with 1 remainder. And so this number becomes 18. 3 6s are 18. And you have no remainder here, so this becomes 0 here, and you have 9. So 3 into 3 is 9. Now let us go to the next one. As I told you earlier, I gave you a small tip that if one number is 3, the next, it has to complete a pair, so the next number definitely has to be 3. Or otherwise, by divisibility test, 3 plus 6 plus 3 is again 12, which is divisible by 3. So now let us go for short division. Here it's very simple. We have 3 1s are 3, 3 2s are 6, 3 1s are 3, no remainder, so it was a direct division. Now 121 again comes in the table of squares. So 11 to 11 is 121, 11 to 1 is 11. So the prime factors of 1089 are 3 into 3 into 11 into 11. Now pairing them and representing each digit, we get square root of 1089 is 3 into 11, that is 33. Again, I repeat the tip: in a square number, the factors are always in pairs. Interesting, isn't it? I hope you enjoyed the session. Thanks for watching.